Hi everyone, in this video we are going to talk about the successive IE of an element. Right, so this is not to be confused with the IE of successive elements, right, where we are looking at the first IE, second IE, third IE, etc. of elements with increasing proton numbers. Instead, this is the same element and we are going to take out electrons one by one, right, all the way from the orbital with the highest energy to the ones inside, right, to the inner shells. So let's get started. So what we need to know is that the trend, unlike the ionization energies of successive elements, this is constantly increasing without any dips at all. Because in the IE of successive elements, you do have certain exceptions, certain dips that you can figure out in other videos. But in general, when you are removing the electrons from an element, alright, it becomes harder and harder because you're removing electrons from an increasingly positively charged ion. Right, so if you remove an electron from an atom, it will be a lot easier than if you removed it from a cation with 1+ charge, which is easier to remove than one from 2+ charge, and so on. Okay, so that is the general trend. So the next thing that you need to take note of is the jump from level to level. So if you look at the energy level diagram, you'll know that if this is my first shell, my second shell is a distance away, my third shell is nearer, alright, to my second shell than the distance between the second shell to the first shell. So if I were to look at the individual orbitals, you will also realize that in n is equals to 2, you can also have your 2s and your 2p orbitals. So what happens is that you'll realize that there's actually a small jump from 2p to 2s, but a big jump from 2p to 1s. So if we were to plot the diagram over here, in terms of number of electrons removed, and on my y-axis it is the energy required, we'll realize that the first electron, right, and the second electron will be just increasing because it is harder to remove from a cation that has increasingly positive charge. Then after which, I will have the third one to remove away all three of them. Next, I'm going to go to 2s. So from 2p to 2s, there's a small jump. So I will do a small jump over here, and then the next one, there isn't a jump at all because I'm still at the 2s. Alright, and finally when it goes to 1s, it's a big jump, and then after that it increases again. So the graph should look something like this, where I can join these points together, small jump, big jump, and basically that is it. And so you can apply this to many other elements too. Right, so in essence, this is how we can plot the graph of successive IE of an element. Right, but do take note that the graph is just a sketch and not a plot. That is why these points do not increase linearly, but in our discussion, right, we just assume that it does. But when we look at actual data, it does not increase linearly. So that is why when we plot the graph, it will look slightly different from this, but just take note of the small jump and the big jump over here.